Okay, now we're going to show you how to use Excel for calculating normal probabilities and using uh, the distribution function. Okay, so let me open a sheet here, a blank sheet. So first I want to show you how this looks like, how the normal density looks like. So I'm actually going to just generate some numbers randomly and let it go all the way to, okay, 3 sigma. Okay, so that's good. So one of the functions that we can use is the norm, and you can see a variety of functions here, but norm.s, that's the standard, okay, standard normal. So the probability of the standard normal being less than -3. So what I'm going to do is I'm going to set the cumulative here. Normally, ignore it. It will be false. It will give you the distribution function. I'm going to actually make it true this time. Sorry, false this time. And I want to just give you a feeling of what the density looks like. So this is a density now. Okay. All right. And for the next, I want to show you, okay, what, and you can just ignore it and it's going to be false. It's going to be true, sorry. Okay, and now you see it's growing. And when we get to +3, it's going to be actually close to 1, if not exactly 1. Okay, so how does it look like? And let's just actually have a representation here. Okay, so this is what it looks like. Okay, and I could just change the labels to the actual values rather than the sequence. Okay, so that is the frequently encountered normal density. So now let me also put on top of this, okay, so we can add now the distribution, okay, and the values will be from the distribution less than or equal to. Okay. And so now you can see that this is the distribution and the blue line is the density, and the density peaks somewhere around 0.4. That's when z is 0. And of course, the distribution goes up until 1. And that's where actually it peaks at 1, and all the way to the right, it will continue in that fashion. Okay, so the red line gives us the area under the blue curve from -infinity up to that point. Okay, so if we want to find, so those are the two functions that can help us. If you ignore that flag, true or false, that is the more practical form. One of the other forms is the norm.s.inv function. So if you get the norm.s.inv, it requires only the probability. So if I input this probability now, okay, it's going to give me exactly -3. So this is the inverse of this function. Okay, so you can see I'm getting back the numbers that I entered. Okay, so if I want to find, referring back to our slides, and we had a case which the mean was 18, okay, and the sigma was 5. Okay, so if we want to find the probability, the download will be less than 18.6. So what we can do is we can just use now the norm.dist function can also be used. Just we have to input the number 18.6, but we have to also input the mean, and we have to input the standard deviation and leave the cumulative option. Sorry, we don't have that right, maybe. And we use true for the cumulative distribution function, and we get 0.54. And this is the answer that we got also on the slides. So we can also consider the greater than side. So if we consider probability of observing a value greater than 18.6, just what we need to do is we need to take 1 minus that. So instead of checking with a table, we could use these functions. Now, if you want to use the .s function, you first need to standardize by 18.6 minus 18, and that you need to divide by 5, and then you can use alternatively the norm.s.dist function. Okay, so that gives you the same answer. So the other thing we had was the in-between probabilities. What if I want to find the probability that the download function will be greater than 17, okay, but less than 18.6. Okay, so then I just have to subtract two values. I already found the probability of being less than 18.6. It's right here. Then I have to subtract it from using another function, norm.dist function. The other ones can also be used. So norm.dist is the same as norm.dist, just from older versions. So then I should put 17, and I have to put 18. I have to put 5. Okay. Now this one requests that we enter that parameter, that final parameter. Okay, so that area under the curve between 17 seconds and 18.6 seconds could be calculated in this fashion. So the other problem we had was, given a value, a probability, find corresponding normally distributed value. So find the download time such that 20% of the download times will be less and 80% consequently will be above. So now we have to invoke the norm.inv or norm.s.inv. So let me first use the first one. Now, if you use that one, now you have to take the mean and use the standardization, but this time going backwards, and you actually find that precise value, 13.79, which gives you approximately 20% below and 80% above. We could also use the norm.inv directly. Now we have to input probability, then we have to input the mean, and we have to input, and it's showing you right there, standard deviation. Okay, and which of course directly gives us the same thing. Okay, so given that 10%, so it might be also nice to take a look at those empirical distributions. So just, the sigma rules. So if I just put norm.s.dist percentage of values less than -3. So you see, it's just, if you consider 100,000, 135 will be less than -3 sigma. Okay. All right. So if you want to read this with the 3 sigma rule, so how many values will be between plus and -3 sigma? So you just have to subtract this one Okay, and you have to subtract that little tail, 99.73. So that's where that rule comes from. And we can also find for the others. Okay, and for the 2 sigma, I should put this one minus tail. For this one, I should use this one minus tail. Okay, so convert this to percentage. Okay, so that's where those rules are actually coming from. Okay, so